Hi guys, let me show you how to perform the density estimation for over the points here. So in here I have the three centers in Singapore. So the first one is Bishan, the second one is Paya Lebar, and then the last one is the Holland Village. So three in here. I use a randomization method in order um, to randomize the nearby points. I won't tell you which method it is, but then later after we do the density estimation, you will know. Okay, so the, in order to perform the density estimation on this one, I will have to I will have to compute the boundary of the whole thing exists. Okay, so the first thing I need to do is to use the spatial tool here to compute the boundary. So the simplest method for in this case is just to use the poly in this case to build the convex hull over the point. I won't group the whole thing, and then I just build everything into the all the point in here into a convex hull and like this. Okay, let me show you how to. So everything will become compiled into one single source, and then if you draw the underlying map for this, you will see the Singapore behind because those points are the bounding box just in Singapore. Okay, so in order to divide those guys into point two boxes, I use the regular grid tool here, and then uh, I use 0.5 km. So Singapore is very small, so if I use, I think 1 km should be okay. But then if you use like 10 or 20 km, it will give you like a few rectangles. Let us see how it goes first. Okay, and then so here you can see the bounding box like this. And then if uh, I want to put the points from here into the boxes in here, I need to mm, I need to use the matching tool. Okay, so mm you also notice that this one is a little bit tricky if you put the points in the box like this. So I will show you how tricky it can be. So I will put the center in here, and then the grid will be the, the U or the under, uh, and then the T will be the input, and then I want the target is within the universe, which is a T. Let me zoom out a little bit for you to see the T. And okay, so the T will be here, the U will be here. So I want the point in T to be within the universe U in here, and then that's all I need. Okay, so I will I will need this one anymore. So I get rid of it. The number and the name is I think is okay, and then grid name I think is okay, and then that's it. So if I run this one, I will get the something like this. So it will show me the grid with the numbers in here. So I need to summarize the one because every time you have the match, it will give me one box. So I have a lot of boxes and I don't want. So I just want to group by the grid name, and then the grid will be the max or the first. So this one with the shape of the box, the name, and then I will count the number of points in here. So it will be the point. Point count. So the count of the point inside the each box, and it was supposed to be like this. So it will take a while to render the thing, and then if you click in here, you can see this box has 3 points. This one is very dense with 40, 43. Now you can see here it's a little bit like incomplete like this. So why this is the case? Because when you have the you have the bounding box like this, if you it's in irregular shapes, and then if you divide into grid, it will show you the grid irregular like this. Okay, so you see the in the bound inside the box is fine, but then in the boundary, within the boundary, it will be a little bit irregular. So in order to fix this thing, if you want to have everything regular, you just use the buffer function here, and you expand the bounding box a little bit into like 2 km. So 2 km, and then if I have more 2 km already, then uh, I I will just I will just use the mm, grid again. But in this case, because this buffering function changed the name already, so I have to rename this a little bit. So if you want to, it's like everything is clean, you just put the uh, function in front like this. You rename by shape or shape, and then you can use the shape in here safely. So after this, you hopefully you have the regular. So you can see here the box was a little bit bigger, and then let us check in here if you have the regular shape. There you see everything is regular, because all the irregular one outside here, they have no point in it, so, and they will be removed. So if you want to see the irregular one, you can see here. But I need to use the browse tool in here in order to see, and then I have to run it again to in order for the browse tool to have the uh, oh, sorry. I cannot use this one, because why? Because there's no so this part of the matching only show the one with without the match at the point here without the match. But then because everybody inside this structure already, so you cannot see, actually eventually you cannot see that. So that's the reason. Okay, so the first thing you need to do with this is to display this box. So it will be very difficult to see this one if you want to see, oh, this is one very big, and then you click in it and then you see, oh, this is where it is, and then this one is a little bit more. So you cannot tell like which one is which one is bigger than the other one in this map. So normally you have to display in the other mm, in the other devices. So for example, if you want to, you can just load this one into Spotfire, or you can just display in uh, Power BI as well, and then you can display in R script as well. So basically, you have to display in different places. Outreach is very good in producing this map, but then it will be difficult to in this browser to display. Okay, so this is the easiest way you can do in order to perform uh, density estimation, which is to uh, produce the box first, and then you can you can use a matching tool to match the two together, and then you group all the boxes together in the same place. Now this one is very trivial case, but then it will show you different extensions from here. The first one is when you have like 1 million points, then how can you do it? So 1 million points is very big. So depends on your computer. So 1 million points in this within this one, maybe you Singapore is okay for, but if you go too much for Indonesia or China or Russia, 1 million point is just very normal. And then how can you run the workflow with 1 million point? That's the first extension from here. So the answer is you cannot do in 1 km square, and you have to do more than 1 km, and then you divide by 2 layers. So for example, if you divide Malaysia into 4 or 8 parts, and then you work on you match on either part, and then inside each part you can match one, uh, so it will be a little bit smaller um, than the whole country. Okay, so that's the first one. The second one is uh, can we this one is actually binning, so this one is just put the match the box and then the point all together in the same place. So if the point is inside the box, and then we just count, put it in the box and then count to one, and then 2 points in the box and we count two. So this one has only one only. So if you want to, actually I can show you how to draw the two all together in the same view as well. So basically, you only need to uh, uniform to union these two together, and then they will appear in the box like this. So you can see here those points are in front, and then if you want to see this, where is it? Is this had only one? Okay, let me zoom out a little bit, and then you can see. Okay, so now you can see how many already. So this point, this. Okay, so the zooming thing, it doesn't work with the. Mm, so this one has the map is it doesn't work with the zooming, so I need to zoom out a little bit. Okay, so the this one has only one, and then you can see it in here. Now this one have 20. Okay, so I think the map doesn't work when you zoom. The map still work, but then the selected one is not working, or it is just slow. Okay, so this one has two, and then you can see here two already. Okay, so uh, oh, it's just slow. Still working, but it's just slow. So you can see here 2 points on top of this box, and then this is how you match. But then the binding is okay, but it just doesn't make sense in general. So for example, if you install a Wi-Fi here, for example, then everybody near your neighborhood can use your Wi-Fi, assuming that you're free and then you don't have any password, and then everybody has to access this one. So if you restrict yourself in only one single, you want to count the number of people who can reach your Wi-Fi, for example, then you cannot count it within your block or within your house. You have to count in the neighborhood. So that's the reason behind. And also the same thing is like, if you open a service in here, for example, in here, then maybe people in this neighborhood and this neighborhood also can go to your place and then enjoy the service. So it's the same concept as, so the signal, the Wi-Fi signal is more about the broadcasting or like spreading from one place to the other. But then in terms of service, service point, so for example, restaurant, and then other people can come in, other people can come into your place and then enjoy the service. Okay, so how to do so the concept is clear, right? So you have to count the neighboring point. So how to do it, and then yeah, can we do it from here? So the answer is yes. You can use the same workflow or the same model, and then you only need to expand your point with a kernel function. So a kernel function or a spreading function or the service function is just a function in which you expand from one point to all the neighborhood point, and then normally you have to discount something, something when you expand. So for example, if you open a shop in here, then you expect that everybody, like 90% of people in the neighborhood around here will come to your place because it's a little bit far away. But then it's when it come to here in another round, a little bit far away, you have to assume that 70% of them come to your service. It's not what 90%, is not like 100% anymore, because it's too far away from your place, and then people get lazy. Okay, so you have to discount a little bit, and then you cannot count like 100% anymore. So that's the idea behind kernel density estimation, and then you can do it from here. So I'm just I just want to highlight 2 points. The first point is like, when you have 1 million or you have large scale data set with 1 million points, then how can you go about it? How you can modify this workflow to get about it? And the second thing is like, you need to expand this one to uh, reflects the reality of a service point and then signal point, in which you have more, you have less service or less signal, or less thing far away from the center, and then a lot of thing in the center, which is specified in your kernel function.